sensors and sensoring technology, instrumentation techniques, wireless sensor networks, numeric field calculation, electromagnetics, and others. He had supervised over 40 graduate students and over 100 students in honor program. He has examined over 50 postgraduate theses. He has published over 400 papers in different international journals and conferences. He's an IEEE fellow, IET fellow, and IET fellow, topic editor of IEEE Sensor Journal, and associate editor of IEEE Transaction on Instrumentation and Measurements. So today, Professor Subhas' topic is Internet of Things and wireless sensor networks for health and home management. So Professor, welcome, and now you can start. Thank you.
Thank you, Professor Liu. Can you hear me?
Yes.
Okay. I think I need to share my screen. So how do I do that? Because I need permission.
I think that in the bottom there's a right button.
Yeah, it's telling me that you must be a presenter, but okay, now I think I got it.
Okay, so we have good IT support from them. They hear your questions. Yeah.
Can you see now?
We see it's loading. We can see it now.
Okay.
Very good. Thank you.
Okay, so thank you very much, Professor Liu, for your nice introduction, and thank you, the organizer, especially Professor Ivan Mula, and all the conference organizer and delegates. So a very good afternoon. For me, it's of course early morning. It's now 7:10 in the morning on Wednesday. So it's my pleasure to deliver this keynote address, and it's like our research, what we are doing for last so many years. So glimpse of some of the activities I'll be sharing with you all. So Internet of Things and WSN, of course, WSN now become a subset of IoT for health and home management. And as Professor Liu mentioned, I'm from Macquarie University in Sydney. So our university, in terms of age, is not very long. It's 1964 it was established. Engineering, even very little time. So end of 90s, the engineering started in our university. So it's like 20 plus years old. But in terms of the contribution in engineering, it's quite significant because our professors, late 90s, they were involved in the development of Wi-Fi chip. And as we all know, Wi-Fi is very much part of our life now. We are living under COVID-19. If Wi-Fi is taken away, it will be really, really hard for everyone to feel their existence now. So our university that way quite significantly contributed.
Sorry for interrupting, Mr. Sola. Your presentation is not in the slideshow. It's the set of slides that you're sharing.
It's not. You are not able to see.
It's in the review mode. I think you don't turn on the slideshow to enlarge each slide. So now it's we can see all the slides in one window.
But I can see only my slides.
Oh, it is that what you are supposed to see, but only you.
It's still the same problem?
Yes. When we just see all the slides. Each one is small. Yeah. Now it's good.
Now it's good.
Now it's good?
Yeah. Very good.
Does it help?
Yeah, it's help.
Okay.
Thank you.
So can you see the slides with my university name?
Now we're on the first slide. The title and
it's not changing.
Second, it's not changing.
Oh, why? Does it change now?
Yeah, it's changed now.
That changed.
Okay, so I cannot go to the slide show mode then. Okay. Yeah. Anyway, I think we'll go like this. I'm not sure the problem. Okay, so I'll continue with that. So our contribution of our university professor in terms of the development of Wi-Fi is significant, and that's everybody can feel that Wi-Fi how important for everyone now under COVID-19 situation. So my group, we do research on sensor. We develop sensor for different applications, which can be healthcare, environment, or industrial applications. We also use sensors which are readily available in the market for making sensing systems. And what we do, we upload the data in the internet by making our sensor internet-enabled sensor, Internet of Things enabled sensors. And sensors are very important for everyone. Long time back, Lord Kelvin told that if we cannot measure it, we cannot improve anything. So for improvement, we need to know the knowledge, and that knowledge comes from sensor. We also use different medical devices for our health, whether we use some of them at home, like thermometer, blood pressure meter, and so on. But most of these devices are actually used in clinic and hospital when someone falls sick and need health care. Many of them give different types of output, can be in the form of printed, but medical devices are not connected to Internet of Things or IoT as such in the current situation. We also have lots of wearable devices. So wearable devices effectively owned by the human on their body. Sometimes we may also include implanted sensors, which is inside the body, can be also a wearable. They are very high power, tiny sensors. They measure physiological parameters, process them, and tell our health conditions. Sometimes they know as wearable gadgets or wearable technology or simply wearables. Of course, due to the advancement of semiconductor technology, high-speed processor, as well as nanotechnology material, that made possible to develop very small, tiny wearable devices. And as we can see, they can be used on top of our body in the form of headband or smart clothes or different types of badge, and more popular is the smart watch. And there can be many types of sensors for measurement of physiological parameters. There are different types of applications of wearable devices to monitor physical or psychological stress, hydration status, muscle stimulations, cognitive feedback, monitoring sleep, evaluation of concussion. So all these things, what we could see that IoT-enabled healthcare, they actually can help significantly in the domain of healthcare if we use or exploit IoT systems for the collections of the physiological data and put it in a common platform which can be used for development of a connected healthcare systems, providing a better patient outcome, reducing the significant healthcare cost, and also makes a better engagement between the patient and the general practitioner or the doctor. So in this area, the growth is now significant. Next 4 to 5 years time, all parts of the world, we could see the market is growing almost 4 to 5 times. Whether it's Europe or South America or Asia Pacific, everywhere this growth is now visible. A few big players contributing in this area are Biotronic, GE Healthcare, Boston Scientific, Medtronic, Johnson & Johnson, Cisco, Welch, IBM, Siemens, and so on. There are quite a few challenges of this happening in near future. Of course, the research and growth will take place at slow pace, but there is a significant challenge. The current funding model is not supportive enough. A big problem for the IoT designer is that interoperability. When we design something, we need a certain standard, but this standards need to be an open standard for IoT-enabled devices. And the biggest concern is the cyber security. So that's something which everybody is very much scared about it. That if we have our physiological data, health data, whether it will be hacked or some privacy will be intruded. So that's one of the biggest concern. We need to address that. And then of course that digital talent and digital capability, there is a lack on that. The trust in the digital age, and of course scaling of the system. There are many areas where we can see IoT-enabled healthcare applications. I mentioned about the home as well as on wearable, on body, but also mainly it is in hospitals and clinics. And also it can be very useful under this COVID restriction in remote areas where people don't need to travel to the big hospital and city if they're not suffering from a disease which can lead their life at risk. In terms of the architecture of these IoT-enabled healthcare systems, we need to allow the data which are measured and collected at any point of their life 24/7 to be stored in the cloud. So whether the person is at home or person is at hospital or even going for a walk, taken by ambulance, any time of the day, we have to make all these devices so that they are enabled and they are uploading the data in the cloud. So that's one of the important things we have to keep in mind. The data are available in the cloud and which can be visible. So this is a typical example, like it is my personal data which I use with my phone when I go for a walk, and it tells me how many steps I do, how much kilometers I walk, and it is stored in my systems. But of course, it needs to be available in the cloud so that my GP, any healthcare provider with significant access can be able to watch and see. But it is only the related to steps and related to walk. We need to have all the data, all the activities. Unfortunately, the system what we have, they're not catering all those applications. It's only part of that, and all need to be connected. In order to make a IoT-enabled node, we need few building blocks. The most important one is the sensors. Sensor need to measure the parameters of interest, and then it need to be processed. After the processing, we will be able to upload the data in the cloud, so we need internet connectivity. And of course, as I mentioned, security is the biggest concern. We need to make the system secure so that there is no foul play. So these are the 4 building blocks for making a IoT-enabled sensor node for healthcare applications. While doing that, we need to use internet transfer, some internet protocol, and with some wireless system. Now there can be many, but in order to make it international standard, it may be useful to follow some IEEE protocol, whether it's a Bluetooth or Wi-Fi or WiMAX or LoRaWAN. Now each one has got its own advantage and disadvantage, but we need to follow certain protocol so that we can make anything which can be used at any part of the world. I will now tell a little bit of our old work. We are working in this area for almost last 15-16 years, and when we started, it was targeted to care elderly people who usually fall down and many accidents happen. So we started with our system for making something in the finger which can be used by the elderly persons, and then we extended it to the as a wrist, not like a wristwatch, but kind of a system on the wrist, and it measures the body temperature, heart rate, and also there is a sensors which is basically accelerometer for detecting the fall. Then we extended it to determine the emotion of the person. The emotion of the person is a very complex thing, but we can only measure a few emotions: person's happiness, sadness, and whether person is angry. That can be used for sending the text to the caregiver that there is a need for help. For example, if the person is very sad, it will be good that somebody can talk to him. Or if the person is very upset, it will be useful that somebody can talk to him. Our big picture is the smart home. Smart home provides a safe, sound, and secure living environment for not only for the elderly living alone, but also people at any age can be very, very useful. We all know that people live much more longer than before, but at old age, when people become 70, 80 years old, they need different types of help for their day-to-day life, but also it is not the help for their daily living. It can provide some help in the dire need when something happens, and this can happen to anyone, not only for the elderly, but also for young people. As we see here, someone in early 40s had some accident and died at home. And this is true. What we see from this data is that people at the age of 15 to 64, irrespective of men or women, almost 1/3 people live alone. And that's why the technology can be very, very useful to address the issue. So our idea is we can have sensors which are two types. Either it can be wearable or also it will be non-wearable. It is not only wearable or it is not only non-wearable. Combination of both can be very, very useful. This is the non-wearable sensors which are used for detecting any appliance which is used for person's daily living, whether it's a bed or it's any kind of electrical devices or water use and so on. And also there is a panic button which once pressed will go to the caregiver and some help will arrive. So that's the whole idea, that all these electronic devices, smart sensing devices, can monitor appliance which is used for the person's daily life, and they send the activity to the central controller which analyze the data, and depending on the data it will decide whether everything is normal or anything is irregular. If something is irregular, then action will be taken. So that's the whole idea, so that persons can live a normal life. We develop different types of sensing systems, as well as we develop different types of sensors as a part of the research. As we can show here, earlier development we have all based on Zigbee based transceiver, because in early 2010, at that time Zigbee was very, very popular. So our devices were based on Zigbee based. Later on, of course, we changed to Wi-Fi and LoRa. So this project, interestingly, it was called Living Lab. So it was a very old house built in 1938, and that house is a 2-bedroom house, and we install the sensor as we see here. It's not the sensor developed in the lab and doing some research there. Of course, that we have done, but once we make the sensor reliable, then we install the sensor in the old house. And this sensor has different types of, this house has different types of sensor: electrical, force, PIR sensors, which is used for the movement detection, as well as ambient sensor, where measure the room temperature and humidity. Number of sensors will depend size of the house, how big is the house, and what are the activities we want to monitor. So that should be decided in the beginning by discussing with the persons we are monitoring. So here we show that the person is being monitored. It's interesting if person has certain kind of hobby, which will be helpful to monitor whether that particular things are used. Other than that, normal things like bed, chair, sofa, the person use every day, watching televisions for the heating of the room, toaster, microwave oven, and so on. And as you can see, these are all connected with the Zigbee based system. Now, of course, you may see that here all wires are visible, which may not be safe, but this is just for the picture we wanted to take, and that's why it is like this. Otherwise, it is safe in the sense that it's not making any health hazard. And this is the gateway which is connected to the laptop. So all these devices communicating with this gateway, and then the computer stores the data and then analyze. Now, these devices are basically all event-based activity. That means if anything happens, then only they will send the data. The whole idea for a technology-assisted home is that the sensors are collecting the data at real time, and data, of course, collected when some event happens, and sends the data with a timestamp, the activity of the data with the timestamp to the system. And this system, once the data is collected, it stores the data, and then it analyzes the data. In the analysis, the main purpose is to recognize the activity. What activity the person is doing. From that activity, we can tell whether the person is living happily or well. We defined a factor called wellness of the person. This type of system also need significant amount of data analysis. We call data analytics or intelligent software, and that software should be adaptive software, because with time things changes, person's habit changes, so the software need to be adaptive. So once the raw sensor data comes, we actually store that all events, and from that first we determine what is the activity the person is doing, and from there we use some probabilistic approach, some time series analysis, and also some pattern matching. All these things gives us that what is the behavior of the persons, whether the person is doing normal things which are expected and person is doing well. So sometimes it's called behavior detection, but we are main emphasizing on wellness detection, how well the person is, whether there is any kind of issue with the day-to-day life of the person. So in computing domain, we call it activities daily living, how the person is living. Here we are showing what type of sensors we need for the person's activity. And in the beginning, we assume that most of the persons will be very similar type of lifestyle, but with some weeks of usage, we determine that some of the sensors are not required for a certain persons, and then we can eliminate that sensors from use. So it is coming from the frequency of daily usage or frequency of sensor usage, what is required, what is not required. And then from the activities of the sensors, we annotate what is the sensor, what is the person doing, whether the person is sleeping, person is taking breakfast, or person has gone to toilet, or person relaxing on the sofa, watching television, so on. And then we define what is the wellness of the person. Now we have two types of wellness. One is based on the inactive usage of the sensors. Another is based on over usage. So inactive usage means if we do not have wearable sensor, that means person is not wearing any sensor and we are totally relying on the non-wearable sensor, it might happen that we are not able to monitor the persons for a certain time. How long that time can be so that still everything is normal. So that's what we say, that based on inactive usage. So we start from 100%, and with time increases, this wellness function, wellness factor changes, and we decide whether it's a 50-60% time we can allow, which can be few hours, so that the person is still safe. Otherwise, we will generate a text message or warning message so that some care should be taken. Another is the excess usage. Excess usage means some particular appliances are used much more than the normal behavior. So for example, usage of bed. So normally bed can be used 9 hours or 10 hours, but if on a particular day bed is continually used, then how long we can wait till we generate a warning message. So these two help significantly to monitor the persons. And also another important thing, that as we are collecting the data and analyzing the data, we can use that old data to forecast or predict the future data. And also it tells us the trend of the persons, how the person's behavior is changing. So that is very significant. At old age, it can tell us whether the person is going to be sick or going to fall illness, something like that. That's very, very useful. So we have seen that this trend helps us also not only for the future, but the future data is used as the reference data, because as the person's habit changing, we cannot take the data which we started as the reference data. So that's very important, that adaptive nature of the system is very, very useful. I will touch the current activities what we are doing in our lab. So we develop sensors for different applications. Our sensor is predominantly interdigital sensors. Earlier days we used to develop everything MEMS based, but now we use both MEMS and the flexible material. So this sensor is the electric field sensors, and in 4-inch wafer we can develop around 35 sensors. As you can see here, it's 2.5 millimeter by 2.5 millimeter sensing area with around 50 millimeter from micrometer pitch. Electric field passes through the material under test, and basically we measure the impedance. So these sensors are known as impedance spectroscopy based sensors. One of the earlier research, we developed the sensing systems to detect the pathogen or E. coli in meat, which tells us whether the meat is safe for consumption. For sensor researcher, one of the important parameter is sensitivity, and the next important parameter is the selectivity. How selectively you can determine something. And here for selectivity we develop called molecular imprinted polymer. So we develop a polymer which is a selective polymer, and it comes as a coating on the top of the sensor surface. It has got some advantages, but at the end we can detect the polymer molecular level. So the process is shown here. We need to make the polymer, which takes some certain procedure, and it takes around 48 hours. Once we have the polymer, we can functionalize the polymer on the top of the sensor surface, and then we can do the experiment. Sometimes if we have gold electrode, we can see the sensitivity is much better than normal sensor. Here we have applications where we can detect the contaminations from plastic bottle, and this was a health significant a few years back, but we can detect with the help of our sensors 2 parts per billion, which is very highly sensitive sensor. Another applications we have recently completed is that early detection of osteoporosis, which is the issue many people face at their age when reach around 45, 50. The bone become brittle and people fall down and break their bone. So that is the indications that people are suffering from osteoporosis. Now, usual procedure takes quite significant time, and it can go up to 1 year to 2 years. But if we follow this method and we can determine very early stage, then the health management can start at early stage. So right now the sensors what we have developed takes a drops of blood, and we can tell how much is the protein, which is called C-terminal telopeptide. It's a biomarker for the osteoporosis disease, and that protein amount can be analyzed with the help of our sensors, and then the data can be uploaded in the cloud, and that data will be seen by the doctor, and when the data reach above the threshold value, then the doctor will get a message, and then of course rigorous testing will be done. So it's the early indications, and that can be very, very useful. Right now the sensors, we rely a drop of blood, but we are thinking that can we actually extend it to urine. So a few years back we thought that this can be a dream, that if we install the sensors in the toilet, we do not need to collect the sample. The urine can be measured, but of course in order to make so, our sensor need to be very robust, because the environment is very toxic environment, so needs to be very robust sensor. So a few years back it was just idea, and we thought that in a future possibility this is an opportunity. But interestingly, I can see now that few groups have started working, and I can see the paper are submitted in IEEE Sensor Journal in this domain. Though we could not do much, because my student after graduation, this has not been taken that interest by other students. We also work on the flexible sensors using different types of nanomaterial, nanocomposite, and also it's very, very useful compared to MEMS-based technology, because MEMS-based technology we need good infrastructure, whereas this one does not require any high-end infrastructure. The flexible sensor, we need to have the base from a material, and then we need to make the electrodes. And once we have that, as we can see here, that the dimension changes. So it's very useful for making this sensor to determine stress or strain type of applications, as well as we can make it selective sensor. So wearable clothes find a lot of applications for this type of sensor. Depending on the material, it all depends on the applications. We can have the base coming from either PDMS, polydimethyl siloxanes, or PET, polyethylene tetraphthalate, or polyimide film. And the electrode, we can have either carbon nanotubes or graphene or aluminium, or in some cases we can use silver or gold, depending on the fabrication facility and also the funding situation. But once you make the choice depending on the applications, then you are ready to have the sensors for doing experiment on different types of samples. So over the last few years in our university, we have developed different types of sensors for different applications, whether for monitoring the physiological activities or monitoring some environmental parameters. For example, we can determine the nitrate contaminations in water, and so on. And all these sensors, when we make it IoT enabled sensors, which means the data is uploaded in the cloud. We are now trying to develop large skin sensors with high resolution and sensitivity. One of the applications is that we are thinking of it can cover a part of the body when somebody is having any accident or a burning issue and the skin is damaged, whether we can replace the skin. Also, in case of robotic applications, we can have this tactile type of sensing with the robot and so on. So we got quite a few applications we are working on, but we need to have large area sensors with high resolution and sensitivity. The current sensor which we see in the reported in the public domain, there are basically many sensors are used together. This is not a many sensor, this is one sensor, but we can actually have many measurement points. That's the difference. Also, we have developed a sensor which can be used in implanted conditions, especially inside the spine of human body. We do not have any trial yet, but next year we are planning to have the trial. Here we already developed a sensor and which we applied for lodged an Australian patent on that. This sensor is very small, again 2 mm by 2 mm, and this can be coming in an array with few sensors inside the spine called interbody cage to monitor the stress and strain distributions of the spine, especially people who are having the back problem. This is the area we are looking for. As I mentioned before, that when we upload the data in the cloud, the security can be a biggest concern. So we also working little bit in the area of security, but it is not too much our own research. It is we are trying to make in our way to make the data secure. So security also we are looking into, but not extensively as a security researcher. We also do another things called access control, because we are developing different types of data. Some data will be more important than others. Some data will be not too sensitive compared to others. So we also make this data different level, and we give access to different people at different power. So whether it's a doctor, whether it's a nurse, whether it's a caregiver, whether it's a relative, whether the person himself, and so on. So this is called access control, which is different form of security. So it's not the security, it's the accessing the data, whether you get the access. So I will end here and I'll be happy to take some questions. So in our lab, basically we develop different types of sensors, and some sensors can be wearable, some sensors can be non-wearable. And basically when we develop such sensors, we actually make the sensor connected to internet so that the data can be uploaded in the cloud and can be used for different types of either data analysis, visualization, and so on. So our main focus is to develop different types of material for making new sensors and with high resolution and sensitivity. And also what we are trying to do is that if all the healthcare data is uploaded in the cloud, and it can be providing a connected healthcare system, that will be very, very useful for future. So I will end here and I'll be happy to take questions.
Thank you so much, Professor Subhas. Thank you very much for your presentation. Are there any questions? I have a question, Professor.
Yes,
for these mini sensors, they're very impressive. But what is their power supply?
So depends on the application. So one of the problem for the implanted sensor that we are thinking of, that power should be supplied from the outside. So we need to make some energy harvesting option. But otherwise, normal sensors, when we use in environmental applications, of course, it depends. It takes usually the solar power based system. So basically, it's not we have a rechargeable battery, but it's not that it will be providing the continuous power. We need to harvest some kind of energy.
Okay.
So depending on the application, so the biggest concern for us as the implanted sensor, that how do we actually provide the power? So that's because the size is the issue. So you need to have very small size. At the same time, how do you actually provide the power? Now, I mean, one of the problem is that that sensor area, if you do not have the communication, then power is not the concern, because we know many people have pacemaker and other types of things, and they can survive 5 years or so. But if you have communication, then it can consume huge amount of power, and that's the biggest issue. And for these applications, implanted sensors, we are looking for the monitoring the status of the implanted body, which is implanted at the spine. So we need to have more energy. So that's what the issue we have at the moment.
Oh, thank you. There's one more question.
Yes, please.
I can read that. The question is, what about time constraint in the context of health monitoring? Priority should or must be exercise, or, for example, what are the main challenge? Yeah, it's case main question. What about the time constraint in the context of health monitoring?
So I think I got the meaning of the question. So basically, it depends on when somebody has health issues. It depends on what type of classifications we have. If something is significantly health, like need to be going to doctor or this, then we can generate the message which is correspondingly like emergency message. But if something which is not so significant, we may actually talk to the doctor, so doctor can call back. If something is normal, then so it is possible to classify in terms of the importance or in terms of the emergency level, and that way it can be done depending on the health parameters. But of course, I have personally seen that most of the time, if we can talk to a doctor, then our 50% of the health situation improve. So it will be important to have the healthcare provider who is a doctor can call back, and if the situation is really severe, then they can take him or her to hospital.
Thank you.
So in terms of the time, if you say that how much is the time it will take, it actually depends on the system provider. So it can go to few minutes to a few hours, depending on the situation. Because sometimes I've seen even in Sydney that when we call emergency help, it can go up to few hours, because in a city where many people and sometimes like many people like to get the help at the same time, and emergency help may not be so many, so they take some priority and they take some time.
Thank you. Any other questions? Okay, thank you so much, Professor Subhas, and it's our pleasure to have you here. Thank you.
Yeah, thank you, Dr. Liu. Thank you, Dr. Ivan, and thank you, everyone. And wish you, I think, I'm not sure that you are finishing the conference, but wish you a very nice time. And I hope that you have enjoyed so far, and thank you very much.
Thank you. Have a good day. Bye.
Yeah, thanks. Bye-bye.